They believed the Pacific Ocean was an impenetrable shield. Distance, they thought, was enough to guarantee safety. No aircraft, no matter how advanced, could cross that vast expanse, operate at extreme altitude, and return consistently. This belief shaped years of planning and confidence. What they did not realize was that, while they trusted geography, the United States was already redesigning the limits of aviation itself, quietly preparing to make distance irrelevant. American engineers approached the challenge differently from the beginning. Instead of asking what had been done before, they asked what would be required to succeed under conditions no one else had fully imagined. Pressurized cabins, advanced engines, long-range navigation, and sustained high-altitude performance were not treated as risks to avoid, but as problems waiting for solutions. Each obstacle became a calculation. Each calculation became a component. Quietly, methodically, a new standard was being built long before the world understood what that standard would mean. The aircraft that emerged was not designed for spectacle or intimidation. It was designed for reliability, endurance, and consistency. Every system was created to function where others failed, under conditions others considered unreachable. Its size, altitude capability, and range were not the result of improvisation, but of deliberate planning supported by testing, refinement, and scale. This was not a single breakthrough moment. It was a collection of decisions aligned toward one purpose, reaching where no defense expected a threat to exist, and doing so repeatedly without failure. From the outside, it was easy to underestimate what was happening. Early intelligence reports describing the aircraft's capabilities were often dismissed or downgraded. The altitude figures seemed unrealistic. The range calculations contradicted known limitations of existing designs. Many believed the information was exaggerated, incomplete, or intentionally misleading. Defensive doctrines remained unchanged because the idea itself felt improbable. It was easier to deny the possibility than to reconsider everything that had been assumed about air defense and national security. The first missions began to erode that confidence. Defensive responses struggled to adapt in real time. Aircraft designed for interception found themselves operating at the edge of their performance limits. Early warnings did not translate into effective engagement. Each attempt to respond revealed the same fundamental problem. Existing systems were built for a world that no longer applied. The aircraft was not violating expectations by chance. It was doing so by design, operating in a space defenders had never truly controlled. What unsettled planners most was not a single appearance, but repetition. The aircraft returned. Routes varied. Timing shifted. Yet the outcome remained consistent. This was not a rare asset deployed sparingly for symbolic effect. It was part of a system designed for sustained operations. Each successful mission reinforced the realization that this capability was not temporary, experimental, or fragile. It was permanent, scalable, and improving with every flight. Behind every mission stood an industrial network unmatched in scale and coordination. Factories produced airframes, engines, and components at a pace that made replacement routine rather than exceptional. Training programs prepared crews to operate complex systems with discipline and confidence. Logistics chains moved materials, fuel, and personnel across oceans with a reliability that transformed distance from a barrier into an advantage. The aircraft itself was only the most visible result of a much larger national effort working in unison. Observers gradually began to understand that the challenge extended far beyond aviation technology. What they faced was an organizational model that integrated engineering, manufacturing, training, and deployment into a single continuous process. Each layer supported the next. There were no isolated successes, no disconnected achievements. Every element reinforced the others. This alignment turned complexity into consistency and innovation into routine capability, something few nations could replicate under pressure. Altitude proved to be one of the most decisive factors in this shift. Existing interceptors were not designed to operate effectively for extended periods at such heights. Even when interception was theoretically possible, performance limitations reduced effectiveness. Engines struggled. Pilots reached physiological limits. Engagement windows closed quickly. The aircraft's operating envelope placed it beyond practical reach, forcing defenders into a reactive posture that offered little control over outcomes and no reliable path to regain advantage. Adaptability widened the gap even further. Payloads changed. Routes evolved. Operational tactics adjusted based on real-world experience rather than rigid doctrine. Each modification improved effectiveness without sacrificing reliability. This flexibility demonstrated that the aircraft was not locked into a single role or method. It was a platform designed to evolve continuously, guided by data, feedback, and refinement, learning faster than any system designed to counter it. As missions continued, the psychological impact deepened. Defensive readiness no longer produced reassurance. Instead, it highlighted uncertainty. The question quietly shifted from whether the aircraft could be stopped to whether any existing system could consistently challenge it at all. That doubt influenced planning decisions, affected morale, and reshaped expectations about the future of air operations in a way no single engagement ever could. For the United States, this capability reflected a broader national philosophy. Challenges were addressed early and at scale, not postponed or minimized. Engineering decisions aligned with industrial capacity. Industrial capacity aligned with training, logistics, and deployment. The result was a system that functioned smoothly under pressure without relying on improvisation or last-minute adaptation. Innovation was not isolated brilliance. It was structured, repeatable progress embedded into the system itself. The success of the aircraft did not emerge overnight. It was the product of years of investment in education, infrastructure, and industrial expansion. Universities produced engineers capable of solving unprecedented problems. Research institutions supported experimentation and refinement. Factories were designed with growth and adaptation in mind. Supply networks were built to absorb strain without collapse. When the moment arrived, the foundation was already in place. Attempts to close the gap revealed its true size. Developing a comparable platform required time, resources, and industrial depth that were no longer available. Even conceptual solutions faced the reality of implementation at scale. The difference was not a single invention or closely guarded secret. It was an ecosystem of talent, coordination, production, and foresight, and ecosystems cannot be replicated quickly, especially under pressure and limited resources. Each mission reinforced a simple truth. The United States had transformed innovation into standard capability. What once appeared extraordinary became expected. This normalization of advanced technology created an advantage that extended beyond any single aircraft. It established a pattern in which progress was sustained rather than sporadic, predictable rather than experimental, and dependable rather than aspirational. Military observers around the world took note. The lesson was unmistakable. Future conflicts would be shaped less by isolated breakthroughs and more by integrated systems capable of sustained performance. Air power, when supported by industry and logistics, could operate independently of traditional constraints. Distance and altitude ceased to be barriers. They became parameters to optimize within a broader strategic framework. Another realization followed quietly but decisively. The aircraft reduced uncertainty for its operators while increasing it for those attempting to respond. Predictability on one side created stability. Unpredictability on the other created hesitation. This imbalance mattered. When confidence shifts, decisions change. And when decisions change, outcomes follow, often long before anyone fully understands why. For American citizens, the aircraft symbolized something deeper than technological success alone. It represented what happens when a nation aligns its talent, resources, and effort toward a shared objective. Engineers, factory workers, planners, and crews were all part of the same achievement. Each role mattered. Each contribution reinforced the whole, forming a collective effort that extended far beyond the aircraft itself. This story resonates because it reveals how preparation becomes decisive. It shows that outcomes are shaped long before they appear in headlines or summaries. Understanding moments like this explains why certain advantages emerge and why others struggle to respond. If this perspective adds value to how you see history, remaining connected ensures you continue exploring the forces that quietly shape global events. The aircraft's legacy is not defined solely by missions flown, but by what it revealed about capability. It demonstrated that organization could amplify innovation, that scale could sustain progress, that foresight could shape events before reaction was possible. These lessons did not end with one conflict. They influenced decades of strategic thinking, planning, and technological development. As operations continued, it became clear that the balance had shifted irreversibly. The aircraft was no longer an anomaly or exception. It was a benchmark. Future designs would be measured against its range, altitude, and reliability. More importantly, strategies would be judged by whether they could match the system that produced it, not just the machine itself. Looking back, the most striking aspect is how quietly this transformation occurred. There was no single dramatic moment of revelation. Understanding arrived gradually, as familiar defenses failed to deliver familiar results. That slow realization carried its own weight, reshaping expectations mission by mission and redefining what air power truly meant in the modern era. What made the difference was not just advanced machinery, but a mindset that valued solving problems at scale. The United States did not ask whether something had been done before. It asked whether it could be done now, with available knowledge, resources, and coordination. That question alone expanded the realm of possibility and reshaped the future of warfare. The aircraft became evidence of a broader truth. When innovation is supported by organization, it becomes unstoppable. When preparation aligns with execution, outcomes become predictable. This is why the story matters, and why similar moments deserve attention. Remaining part of this channel ensures these patterns are not overlooked or forgotten as history moves forward. The next chapter follows the same logic. A different era, a different rival, the same belief that limits would hold. And once again, the same realization that American technology had already moved beyond them. By the time that truth was fully understood, the future had already advanced.